You designed the acid correctly. Right concentration, right volume, right additives. Then why did the well fail? Because the acid never reached the problem. This is the reality. In matrix acidizing, chemistry does not fail. Placement does. You are not just injecting fluid. You are deciding where reactions happen. Today we focus on two things that actually control results: what you put into the acid, and where that acid actually goes. If you get both right, you fix the well. If you miss one, you create damage. So the real question is no longer, what acid should I use? It becomes, where will that acid react? 3 limits control matrix acidizing performance. First, reaction control. Acid reacts too fast, too early, or with the wrong materials. Second, fluid distribution. Acid does not go where you want. Third, secondary damage. You fix one problem and create another. The critical failure is distribution. Fluid always follows the path of least resistance. That means high permeability zones dominate flow. But the problem is in low permeability zones. So the zones that need treatment receive the least acid. That is the paradox. And that is why many treatments fail, even when the chemistry is correct. This lesson solves that gap. Control the reaction, control the placement, and prevent creating new damage. Additives exist for one reason: to control reactions you cannot see. Each additive solves a specific failure. Corrosion inhibitors. Protect the steel, not the reservoir. Clay stabilizers. Stop fines from moving after you remove them. Ion control. Prevents FeOH3 precipitation. Most iron comes from tubing, not formation. Surfactants. Prevent emulsions and improve cleanup. But if incompatible, they reduce permeability. Retarders. Slow the reaction. Not to reduce strength, but to increase reach. Mutual solvents. Restore wettability and clean residues after treatment. Now the key insight. Every additive solves one problem, but can create another. So the rule is strict. If it is not tested, it does not go in the design. You are not building a mixture. You are controlling a reaction system. The treatment is not the acid. The treatment is the sequence. Preflush removes calcium and prepares the system. Without it, HF forms CaF₂, and CaF₂ does not dissolve. Main acid does the actual stimulation. Only now can the chemistry work correctly. Overflush protects the result, pushes spent acid away from the wellbore. If skipped, reaction products stay and reprecipitate. Key number 4 feet. Inside this zone, any precipitation destroys performance. Beyond it, the effect is minimal. So understand this clearly. The reaction is only half the job. The cleanup is the other half. And engineers fail more often in cleanup. 2 execution methods. 1 principle: control versus simplicity. Bullheading: simple, low cost, minimal control. Fluid enters all zones, but again, prefers high permeability. So most treatments miss the target. Coiled tubing, targeted delivery. You inject exactly where needed. You bypass dominant zones. This changes everything. Better contact. Better efficiency. Better results. Higher cost, yes, but predictable outcome. So the rule is simple. Uniform reservoir bullheading works. Heterogeneous reservoir, you need control. If you choose the wrong method, you accept failure before you start. Same well. Same chemistry. Different result. Case 1. Bullheading. No placement control. Limited additive design. Result: acid flows to high permeability zones. Damage remains. Precipitation forms. Production barely changes. Case 2. Full system applied. Preflush cleans the path. Main acid removes damage. Additives control reactions. Coiled tubing targets placement. Overflush protects the result. Outcome: uniform treatment, restored permeability, strong production recovery. So what changed? Not the acid. The system. That is the difference between theory and execution. Acidizing is not chemistry alone. It is a controlled system. Additives manage reactions. Placement controls where reactions occur. Without placement, chemistry is wasted. Without chemistry control, placement creates damage. Fluids follow physics, not intentions. So diversion is not optional. It is required. Bullheading gives simplicity. Coiled tubing gives control. The final rule: chemical design and placement are not separate decisions. They define each other. Design them together, or expect failure. This lesson gives you control. Not over the acid, but over the outcome. 3 controls: reaction, placement, cleanup. 3 failure points: wrong chemistry, wrong placement, unfinished system. If you fix all 3, you restore flow. If you miss one, you create new damage. Final truth: acid treatments fail far more from placement errors than from chemistry mistakes. So stop asking, is this the right acid? Start asking, will this acid reach the problem, react correctly, and leave clean? That is real engineering.